Hello, today we're going to look at a word problem given during junior round 1 of Singapore's mathematical Olympiad. Uh, let's start by reading the question together. 2 secondary 1 and M secondary 2 students took part in a round-robin chess tournament. In other words, each student played with every other student exactly once. For each match, the winner receives 3 points and the loser 0 point. If a match ends in a draw, both contestants receive 1 point each. If the total number of points received by all students was 130, and the number of matches that ended in a draw was less than half of the total number of matches played, what is the value of M? In other words, we are asked to find the number of secondary 2 students. Okay, so how are we going to go about this? Well, let's write down what we are given, okay? So we know that there are 2 secondary 1 students and M secondary 2 students. Total number of participants therefore is M plus 2. So how many games are played in total? Okay, each student plays once against every other opponent. Well, first student, let's say, plays against all opponents, all the remaining opponents, which means he's not going to play against himself. So he plays M plus 1 games. The second student, so we already counted his game against the first student, so he has to play against remaining opponents, which is going to be now M, because he's not going to play against the first guy, and then he's not going to play against himself, obviously, and so on. So the third student going to play one less game, and the last student, so he already played against everyone, so we're gonna just count 0 for him, right? So he already played against all the other participants. We already accounted for that. Well, this is just a simple sum, right? So what we have an arithmetic progression, and the sum ends up being M plus 1 times M plus 2 divided by 2. Now, note that for every winner there is a loser, and for every draw there is another draw, right? So for each game, we're gonna have 2 outcomes, winner and a loser. So total points is gonna be winning points 3 plus 0, or it's gonna be a draw, which is gonna be 1 plus 1, 2 points. So let's say there are W games that ended with a clear winner and a loser, and D games ended in a draw. So then the total number of points is going to be 3 times W, right? So we don't have to worry about losers because we don't get any points, plus 2 times D, because each game, when it ends in a draw, there are 2 points awarded. And for the game that ends with a loser and a winner, there are 3 points that are awarded. So 3W plus 2D has to be equal to 130, right? We are given this. Well, number of winners and the draw is the number of total games played. We already know that the total number of total games that is played is M plus 1 times M plus 2 divided by 2. So winning games plus draw games have to end up with exactly the same outcome, right? Now I have 2 equations, right? Equation from the consideration of the points here, and equation from the consideration of the number of the games above, right? So 2 equations from the points and from the number of the games played. I just got this by multiplying both sides by 2. Now let's move to the clear sheet of paper and just copy this equation. Okay, so how are we gonna solve these equations? Right. So if I subtract from the second equation the first equation, what I end up with is just W, right? 3W plus 2D minus 2W plus 2D, so you just have W. and it's equals to 130 minus m plus 1 times m plus 2. So this is a number of games that end up with a clear winner and a loser. Well, one condition that we must note, it has to be bigger than 0. You cannot have a negative number of games that end up being, that end up in a winning or a losing. Always, number of games is always positive. It goes without saying that it has to be an integer, but there is no issue here because we know that m's are integers. So the only thing we have to worry about that this is positive. Well, now we're going to start figuring out what w is by just plugging different numbers for m. So if we plug 1 for m, then we end up that w is equals to 130 minus, if it's 1, so it's going to be 2 times 3, which is 124. And if m is equal to 2, the number of games that end with a winner and a loser is going to be 118. And when m is 3, is going to be the number of games that ended in a winner and a loser is going to be 110, and so on, until we get to point where m is equal to 10. If m is 10, then number of games that ended with a winner and a loser are going to be 130 minus 11 times 12, which is minus 2. So this is not possible, right? You cannot have a negative number of games. So we cross this out, and we know that m can be any number from 1 to 9, but not greater than that. Any integer number from 1 to 9, but not greater than that. Well, now let's identify the number of games that ended in a draw. So for m equals 9, we know that the games that ended with a winner is 20, and if we plug this 20 here, it's going to be 3 times 20, which is 60, plus 2d equals 130. If we subtract 60 from both sides, this is going to end up being 70. So 2d equals 70, or d has to be equal 35. So the number of games that ended in a draw is 35, and if I go plug 8, so what I end up with is a number of games that ended with a winner is 40, then draw is going to be 5. If I plug m equals 7, here I'm going to end up with winners 58, and then number of games that ended in a draw minus 22. So here, I mean, there is no point in going any further from here because we cannot have a number of games that ended in a draw to be negative, right? So we could have just stopped here. Now let's look at what question is saying. So the key sentence is one of the last sentence where it says the number of matches that ended in a draw was less than the half of the total number of matches played. In other words, number of draws has to be less than the number of winning games, right? That means that there is only one possible choice, which is draws is 5. The number of games that ended in a win has to be 40. So this one will not satisfy this, because here number of draws is 35, which is bigger than 20. And our answer would be number of secondary 2 students, or m, has to be equal to 8. And that's the answer to this problem.